be aware, sometimes even really short problems are a lot of scratch work. This is a very good example of that. In a recent survey, a 12-year-old gave a movie score a score of 4, while a 55-year-old gave it a score of 7, a 32-year-old gave it a score of 6, and a 62-year-old gave it a score of 8. Based on these 4 responses, what is the correlation between the age of the moviegoer and the score of the movie? Okay, so seems like a simple question. What was all those numbers that I just rattled off? Oh, must have been some data. Right, we just need to calculate a correlation coefficient, the formula for which, no problem, we just need to fill out this expression. I'll copy it here. Oh, wait a minute, that's only the top of it. The correlation coefficient, the formula is essentially a fraction, and look out, because the bottom has 2 halves. Sum of x squared minus sum of x. Square that. Wait a minute, that's only half of it, because that's multiplied by, repeat what I just wrote, except put y's instead of x's. Oh, and then wait a minute, did I even leave enough room for it? All of this in the bottom is under a big square root. Oh, okay. Now, you can actually just look that formula up in a book. But the reason that I wrote it out here is, yeah, the key to actually answering this question is just basically good formula habits, filling out this formula. Now, wait a minute, what was it that I wrote? Each of these is a piece that we're going to deduce from the data in here. Now, wait a minute, I kept writing sigma for sum of x, y, sum of x, sum of y. That's what all that means in here. Wait, where are the x's and the y's? In this problem, x would be age of the moviegoer, and y would be the score. Oh, right, because what is this formula called a correlation coefficient all about? It gives you a single score, a number between -1 and 1, that expresses the strength of a linear relationship between 2 things. The 2 things are x and y, generally speaking, or in our case, the age of the moviegoer and the score they actually gave it on the movie. Do we think there's a relationship between that? Oh, now having written that right here, yeah, the key is just stay organized. Why don't I go ahead and organize the information up in here? Let's see. The 12-year-old gave the movie a score of 4, right? I'm just using this information. The 55-year-old gave it a score of 7. The 32-year-old gave it a score of 6. And the 62-year-old gave it a score of 8. Okay, now I can move this around where I don't necessarily have to keep looking at the paragraph. Oh, because to fill out the formula, I need to find out, for instance, n. Wait a minute, well, I see x, I see y, I don't see n. What is n? Remember the little lowercase n? It's not just correlation coefficients, this comes up a lot. Little lowercase n is the classic symbol for sample size. So if I was to fill out this formula, one of the numbers that I need to fill out the formula is the sample size. In this case, it is, in gathering all these movie scores, how many moviegoers did we bother to talk to? 1, 2, 3, 4. Okay, n is easy. N is 4. Probably the best thing we could do at this point is collect up all these puzzle pieces before we actually work this formula, so to speak. So, 2 easy ones are right here. Remember, sigma means sum of. Okay, I'm going to need the sum of x. Oh, that's just no problem. Add up that column I created, right? So I added that up, I got 161. So I can, why don't we have like a little storage space over here, sum of x, 161. I found that. That's going to go here, it's going to go there. sum of y, add up these, I get 25. And I will note that again over here, sum of y, 25. Now, what other pieces, because I skipped out something in here, sigma sum of x times y, sum of x, y. Oh, you know what I need to do? I need to expand my table a little bit here. Maybe make another column right here, x times y, because what I need is I need the sum of each of these multiplied times each other. Okay, well, 12 times 4 is 48. I'm going to store that temporarily. 55 times 7, I get 385. 32 times 6, I get 192. 62 times 8, I get 496. Now, what I want is the sum of all of those. So I add those up, I get 1,121 on my calculator. And I'm just going to repeat that now that I found it over here. 1, 1, 2, 1. That's what I got. Now, okay, we could fill out the top part of the formula yet, but we don't have, whoops, here's something we don't have. It says the sum of x squared. Now, what this means is add up all the x's. Now, these are the x's, except square them first. This would be another case where it would be good to have another column to first figure out what the x squareds are and then add them up. So 12 squared is 144. 55 squared, I get 3,025. 32 squared, I get 1,024. And 62 squared, 3,844. We did that because we wanted to know what they totaled up to. I get 8,057. So I will just add that to the inventory. Found that puzzle piece, 8,057. Now, what don't we have here? X squared we have, and, oh, wait a minute, sum of y squared. We need to repeat this process for this column of data as well. Okay, so 4 squared a, I can do that in my head, that's 16. 7 squared is 49. 6 squared is 36. And 8 squared is 64. I add up this column, I get 165. That is my add up the y squareds. 165. Okay, I think I finally have all of the pieces I need for this rather large formula, one of the largest formulas you could manipulate in operations management. All right, now the rest of this is just good craftsmanship. We're literally assembling something. So I'll work down here. Let me scoot this up. Rho, lowercase r, traditional symbol for the correlation coefficient is n is 4. 4 times the sum of x times y. Okay, sum of x times y, remember over here was 1, 1, 2, 1. Here, I'll make like a little star for multiply. Got to multiply those. I'm just settling things into place. Minus the sum of x times the sum of y. Okay, they're over here, so minus 161 times 25. That's just the top. Down here, sum assembly required. Remember, there's 2 halves. Got to stay organized. In this half, we have 4 times the sum of x squared, which we found. That was 8,057. That's where the 8,057 goes. And then minus, we're still inside these brackets right here. Minus, you say, well, minus the same thing, the sum of x squared. But this is not the same thing. This is the sum of x. Remember that? You add up the x's. 161. Square that. You'll find that that's a different number. Okay, and then that's only half of it because that's only the half with the x's. Here's the half with the y's. It's the same 4, except 4 times the sum of y squared is 165. Minus the sum of y, which was 25 squared. That would finish off that half, Those two are multiplied times each other to get the finished product, but all of that I do have to remember is under a square root sign. Okay, so those are the numbers in place. The only other thing that we need to remember for success here is order of operations. Remember, you always multiply and divide before you do your addition and subtraction. So I can simplify this somewhat by doing some of the multiplication. See if you get the same answers that I do. All right, in here in the top, we're working our way towards the answer. I get that the top becomes the equivalent of 4,484 minus 4,025. Two very similar looking numbers right in here. Divided by, okay, I didn't take the square root yet because it's getting complicated. I only did the work in here. I get that that first half is a rather large number, 16,227 times, it's that times right in there, haven't done it yet. I get that this part comes out to only 35. So on my calculator, the top comes out to 459. The bottom comes out to 466, and I had to take the square root, right? So that it turned out a little messy in terms of decimal places. I rounded to 2 decimal places, 0.85, which means that when you do that one final bit of division, we're getting something that is awfully close to 1. I get 0.983, of which, yeah, I had to do a little bit of rounding there. But what it's indicating is actually pretty distinct. The correlation between the age of the moviegoer and the score on the movie is 0.983. What does that actually mean? Remember, correlation coefficient varies between -1 and 1. This one came out really close to 1, which is to say it is very strong positive correlation.